Every image you see on your screen is an illusion. We think we are looking at raw reality, but we are actually looking at a brilliant mathematical compression trick called JPEG. JPEG exploits a flaw in human biology. Our eyes have millions of photoreceptors, making us incredibly sensitive to light intensity, called luminance, but much weaker at detecting fine color details, or chrominance. By keeping all the brightness data but throwing away half the color info, we reduce file sizes immediately without you noticing a thing. Next, the JPEG algorithm splits the image into isolated matrices of 8 by 8 pixels. Within each block, every pixel contains a value from 0 to 255 representing its brightness. But trying to store all 64 individual numbers directly is incredibly inefficient. We need a way to look at patterns, not individual dots. This is where we transition from space to frequency using the Discrete Cosine Transform, or DCT. The DCT acts as a mathematical prism. It translates our 64 raw brightness values into 64 frequency coefficients. The top left represents the average brightness of the entire block, while the bottom right represents high frequency, complex edge details. Think of it this way, the DCT asserts that any 8 by 8 block of pixels can be rebuilt by stacking 64 basic patterns of waves, each multiplied by a specific coefficient. Low-frequency patterns are smooth gradients, while high-frequency patterns are sharp, rapid zebra stripe changes. By assigning a weight to each wave, we can perfectly reconstruct any pattern. Now comes the magic, quantization. This is the only step where data is actually lost. We divide our raw DCT coefficients by a custom quantization matrix, then round to the nearest whole integer. Because the human eye barely notices high-frequency variations, we divide those elements by very large numbers, turning almost all of them into clean, compressed zeros. Finally, we serialize this sparse matrix. Instead of reading row by row, we trace a zigzag path starting from the top left DC coefficient down to the bottom right. This clusters all the newly formed zeros together. We then run a simple algorithm to store these sequences of zeros in just a few bits, resulting in incredibly high compression. By exploiting the limits of human biology and the beautiful properties of the discrete cosine transform, JPEG shrinks images by 90% with virtually no visible degradation. The next time you load a page, remember, you are not looking at a photograph, but a highly optimized mathematical trick.